Hello and welcome to the first video of the first series on my channel. On my channel, each series will pertain to a single project, and the first video will define the problem that I'm trying to solve. As an introduction, we will cover three things. First is the general topic of the project. Second, a definition of the problem that we are trying to solve. This is a problem that I have faced, and my circumstances might not exactly mirror yours. If my definition, which is the yellow circle, matches yours, then great. Else, it's important for you to be aware of the overlap and also of the part that won't be covered by this series, as you will have to address that yourself. Here in the diagram, you have a few options to address the blue shaded part. First, you can use other sources, be it other YouTube videos or tutorials to cover it. But if you are following along as I make these videos, then you can comment below the videos, which I will try to answer, or if there is sufficient interest, make it part of the series. Lastly, we will also define the how of solving. So let's jump right in. This series will address a problem with the central heating system. Heating is very relevant to people living in cold climates or places with a high swing in temperatures. Yes, this is a basic necessity of life in these places. It is also one of the major, if not the highest, monthly expenditures in terms of monthly bills. We will look at making the system more attuned to comfort while at the same time keeping the bills down by driving up efficiency. The type of heating systems covered will be systems with a central control, be it basic or smart. The series pertains to multi-room heating only, and in particular, my setup is that of a gas-powered boiler with radiators in every room. I currently have a central thermostat, which is not smart. So, what are the problems or the shortcomings of my system? First, and possibly the easiest to solve, is that of unequal heating across the rooms. What I experienced was that while the heating was on, certain rooms will get very hot while others were still cold. If I was in one of the cold rooms, I had to keep the heating on, and which meant overheating certain rooms, which was a waste. There may be a few reasons for this inequality. Firstly, for us to start from a known good state, you need to ensure that all your radiators are balanced. Here is a link to a fine video which I followed to good results. The other might be that certain rooms, due to the presence of external walls or other heat sinks, are inherently cold, and they might need a tweak on the balance for extra heat or other supplemental source of heating. When I had equal heating though, my main problem was that of a single thermostat. My thermostat is located in my hallway. It monitors the temperature of the hallway and switches on and off based off that. I do not live in my hallway, so the main control mechanism of my heating has no awareness of the temperature that I am experiencing. Smart thermostats can be remote controlled. However, I was not looking at a manual solution where I need to switch on and off. That beats the whole purpose of having a thermostat in the first place. Additionally, out of the rooms of my house, most times only some are occupied. The rest are not. The thermostat currently has no way of knowing which rooms are occupied and therefore most relevant to heat. Lastly, I want the system to know when there is no one in the house and switch off the heating automatically. Having defined the problem, let's take a look at the boundaries of our solutioning process. Firstly, it will be agile. That means we will not wait for a final utopic solution, but instead make versions, iterations towards that final solution. These versions will be put into use immediately, and we will get real-world feedback from these to build the next version, which will be hopefully better. This is a central concept of Work in Progress, my channel in general. Secondly, we will defend ourselves from over-engineering the solution, something I have been guilty of in the past, of being extra. And lastly, periodically, we will check the version with our problem statement. If the current version solves the problem as stated, then we have met our goals and our work in progress solution is good enough and we will be done. So, what do you need to follow along in this series if this is relevant to you or interests you? We will be using certain hardware and software components. We will be using an IoT microcontroller, the ESP32. We will be using sensors for checking occupancy and temperatures, and we will also need something to power our microcontroller. Ideally batteries, so they can move around freely. We will be using C++ to code using either the Arduino IDE or Platform IO. And lastly, we will need something to be the brains of the operation, something that is always on. I will be using a Raspberry Pi for this, but you can use other options. We will cover this down the line. For knowledge and skills, we will require basic programming skills, preferably in C++, but I believe programming knowledge is transferable between languages. We will also be assembling hardware, so breadboarding, soldering skills will be required. I do admit I am no brick Clive, but I do know which end of the soldering iron to hold. With all that covered, we will hit the road in the next video to get the first version of our solution in place. So let's get this work in progress. Thanks for watching.